wonderful scientists. It's another basic science class with Miss Andres. You are welcome, and I trust you are excited for a fun learning session because today's class promises to be very interesting and fun. And before we start, make sure you have the following. You must make sure you have your notebooks, your biro or your pencil or anything you'll be using to write. So our focus for today is levers, mechanical system, and mechanical advantage. So we'll be looking at levers, mechanical system, and mechanical advantage. So the first thing we'll be starting with is lever. What is a lever? A lever is a simple machine that is used for doing different things. So different things like what? A lever can be used to move heavy objects. A lever can be used to cut materials. A lever can be used to move anything. We'll be looking at the components of a lever. What did I say? The components of a lever. Now, a lever is made up of three components. How many components? Three components. A lever is made of load, effort, fulcrum, or the pivot. Repeat after me. Load, effort, fulcrum, or pivot. So what is a load? This is the weight of objects to be moved or carried. So the objects to be moved or carried is known as the load, and it is also the force to be overcome by effort. Now the next is effort. What is an effort? This is the force applied at one end of the lever to move or lift the load. So the force applied at the end of the lever to move or lift the load is known as an effort. Beautiful. So the last is the fulcrum or the pivot. So what is the fulcrum or pivot? So this is the turning or rotational part of a lever. So the turning or the rotational part of a lever is known as the fulcrum. So next we'll be looking at the classes of lever. Repeat after me. Classes of lever. The lever has three classes. How many classes? Three classes. So we have the first class lever, we have the second class lever, and we have the third class lever. You watch the video for more information and explanation of the classes of lever. Happy viewing!
A lever is a simple machine, and they are the basis of many tools in and around your house and work. Levers are also found in the human body. The way a lever works is that a force is applied at a point, which moves a load at another point through a balance point called the fulcrum. It's the position of these 3 points, the force, the load, and the fulcrum, that distinguishes the type of class of lever. There are 3 classes of levers: first, second, and third. With a first class lever, the fulcrum is in the middle and the force is on one side and the load is on the opposite end, much like this seesaw. Other examples include scissors. Here's the force, the fulcrum, and the load, and pliers. Second class levers have the load between the force and the fulcrum. For example, with this wheelbarrow, here's the force, the fulcrum, and the load. A nutcracker is an example, and a stapler. A third class lever has the fulcrum on one end, the force in the middle, and the load on the other end. For example, with this hockey stick, this rake is a third class lever, and a hammer. Here's the fulcrum, the force, and the load. Now let's take a look at this easy mnemonic device to help you remember the different class levers. First, you write out FLE, kind of like you're fleeing from someone chasing you with a lever. Next, underneath, write 1, 2, 3. The letters stand for fulcrum, load, and effort, and tells you what's in the middle. The 1, 2, 3 is the type of class lever. So with a first class lever, the 1 is under the F, so a first class lever has the fulcrum in the middle. A second class lever is under the L, so a second class lever has a load in the middle, and the third class lever, which lines up with the E, has the effort in the middle.
I know you have a better understanding of the classes of lever, and you can remember our acronym to know the three classes of lever. What is it again? FLE. F-L-E 1, 2, 3. FLE 1, 2, 3. So now we'll be looking at mechanical system. We'll be looking at mechanical system. What is a mechanical system? A mechanical system is a complex collection of machines and other mechanisms that work together to perform a task. When you have more machines working together to perform a task, what you have is a mechanical system. A device that has a mechanical system working within it is often called a complex machine. A complex machine consists of two or more simple machines working together. What did I say? I said a complex machine consists of two or more simple machines working together. An example of a mechanical system is a bicycle. So we're going to be looking at mechanical advantage. What did I say? Mechanical advantage. Mechanical advantage is how much a machine multiplies the effort put into it. When we use simple and complex machines, we are striving to gain a mechanical advantage, meaning we are trying to multiply the effort force put into it. Now, there is a way to calculate a mechanical advantage, and it is effort arm divided by resistance or load arm. So the resistance arm is also known as the load arm. So anywhere you see load arm, know that we are also referring to the resistance arm. Watch the next video to know how to calculate a mechanical advantage.
The arm joining the effort to the fulcrum is the effort arm, or the distance between the effort and the fulcrum. Load arm, the arm joining the load and the fulcrum, or the distance between the load and the fulcrum, is known as load arm. And it's the length of the load arm and effort arm of the lever that decides the mechanical advantage of that type of lever. Now, let's see the effort arm and load arm of different types of levers. Class 1 lever, that has fulcrum in the center here. This is the load arm of the lever. That is the distance between the load and the fulcrum. And this is effort arm of the lever. That is the distance between the effort and the fulcrum. Remember, the rule is the longer the effort arm, the larger the mechanical advantage of the lever. Now, let's learn it with examples. Here we have a class 1 lever. So this much is the effort arm. And load arm is the distance between the load and the fulcrum. So this much is the load arm. So you can clearly see over here that the effort arm is much longer than the load arm. So this lever will give a large mechanical advantage. The effort arm should be longer for getting the work done easily. Scissors, too, work on the principle of lever. This is its effort. This is fulcrum. And this is the load area. Here we place the load. The nearer the load, the more easily it will be cut, as the load arm would be smaller in that case. So if you want to cut a cardboard with scissors, placing it here will be difficult. But if you place it nearer to the fulcrum, the cardboard will be cut more easily, as the effort arm would be longer and load arm would be shorter. As 2 levers, where the load is in the center. So in every case of class 2 lever, the effort arm is much longer than the load arm. So Class 2 levers are mostly used for heavyweight activities. Examples of Class 2 levers include a wheelbarrow, lemon squeezer, bottle opener, nutcracker, where effort is in the center. So here, in every case, effort arm is going to be smaller than the load arm. Therefore, larger effort is required to do a very small work. This type of lever is used to do very light jobs, like tweezers. Effort arm is much smaller than the load arm here. Here are more examples of Class 3 levers. And in all the cases, effort being in the center, the effort arm is much smaller than the load arm. And how to find mechanical advantage in the case of a lever. Mechanical advantage is the measurement of how much a simple machine multiplies a force. The bigger the mechanical advantage, the lesser force you need. Let's learn it with examples. We know lever has an effort arm and a load arm. And the bigger the effort arm, the bigger the mechanical advantage. We can also calculate the mechanical advantage, and that is by dividing the length of effort arm by length of the load arm. Let's learn it with examples. Length of the effort arm is 40 centimeters, and length of the load arm is 10 centimeters. And 40 divided by 10, we get 4. So, mechanical advantage of this lever is 4. That is, it will multiply the applied force by 4. If you apply 10 kg force, it will make it 40 kg force. In other words, in order to lift a weight of 40 kg, you need to apply a force of 10 kg. Here is another example. The length of the effort side is 60 centimeters here, and the length of the load side is 20 centimeters. Now, how can we find the mechanical advantage here? And the mechanical advantage is length of effort arm divided by the length of load arm. So it will be 60 divided by 20. That is 3. So the mechanical advantage in this case is 3. In figure A, the length of effort arm is 20 centimeters and load arm is also of 20 centimeters. So mechanical advantage is 1. In figure B, length of effort arm is 20 and load arm is 5 centimeters. So mechanical advantage will be 20 divided by 5 equals to 4. And the higher the mechanical advantage, the lesser the force required. Here is a Class 3 lever, where effort is in the center. Effort arm is always much smaller than the load arm. And mechanical advantage is always less than 1. Less than 1 means it does not multiply the effort applied. Third-class levers do not give mechanical advantage. Examples of third-class levers include a fork, a stapler, and a tweezer.
Wow, what a lovely class. So quickly, we'll be looking at the summary of today's class. We started by talking about lever, then we looked at the components of lever, the classes and examples. Then we went ahead to look at mechanical system. We said a mechanical system is composed or it consists of 2 or more simple machines working together to perform a task. Then we went ahead to look at a mechanical advantage. Then after that, we watched a video that taught us on how to calculate a mechanical advantage. Thank you for watching. Do not forget to attempt your quiz and of course do your assignments. See you in class. Bye.